All right, so you've been using or building with generative AI for a bit. You're probably past the basic what is it phase. You're in the trenches now, and you're hitting the trickier questions, the ones that pop up when you actually try to make this stuff work reliably. Well, in this explainer, we're going to tackle 10 of those essential questions to give you a much deeper, more practical grasp on how large language models really operate. Let's get into it.
We're going to break this down into 3 parts. First, we'll peek inside the LLM's mind, to really understand its core mechanics. Then we'll get practical and talk about how to take control of what it spits out so you can make it work for you. And finally, we'll tackle the big one, how to navigate truth, error, and of course, those infamous hallucinations.
To really get good at using these tools, you've got to start with the fundamentals. How do they actually put words together? How do they learn, or maybe more importantly, not learn? And where's all this information really coming from? Okay, first up, you've seen this a million times. You ask for an email, it writes the email, and then it just stops. It doesn't keep rambling on forever. But here's the thing, it's not making a conscious decision to stop. The whole process is purely mechanical. And believe it or not, the LLM isn't actually the one making that final call.
So the LLM itself is kind of a one-trick pony. It does one thing over and over and over. It predicts the very next token, which is just a word or even a piece of a word. The real magic, the control, comes from the software that's running the model. It works like this. The software feeds the LLM your prompt. The model spits out a single token, and then the software sticks that new token onto the end of the prompt. Then it feeds that slightly longer prompt right back to the model, which predicts the next token. This little loop just keeps going until an external rule tells it to stop. That could be the model predicting a special, invisible, end-of-sequence token, or it could just be a hard limit set by the software, like hitting 500 words.
Now this is a big one. It's a really common assumption. You see the AI make a factual mistake, you correct it right there in the chat, and you think, great, I just taught it something new. But does your correction actually update the model's core knowledge right then and there?
The answer to that is a hard no. And this is a really critical concept to get your head around. Your one-on-one correction does not immediately go in and rewire the massive neural network of a model like GPT-4.
So why not? Well, think of the base model like a finished, printed, published textbook. You can't just scribble in the margins of your copy and expect every other textbook in the world to magically get your update, right? Your correction might get collected as data, and it might get used in a massive, super expensive retraining process that happens weeks or even months later, but it is not instant. And yeah, some apps have that memory feature, but that's just for personalization. It's designed to remember things about you, like your name, or that you like your emails to be short and punchy. It's not for correcting the model's fundamental understanding of facts about the world.
Okay, so if it doesn't learn in real time, then what's going on when it seems to remember something you talked about last week? And if its training data was cut off last year, how in the world can it tell you about something that happened yesterday?
The secret here isn't memory. It's all about context. The LLM itself is completely stateless. It has no memory at all. It's the application around it, like the ChatGPT interface, that's doing all the heavy lifting. For old chats, it might pull relevant details about you from its memory and then invisibly stuff them into your prompt behind the scenes. For new events, it does a live web search, grabs the key points, and injects that information into the prompt too. The LLM only ever knows what it's told in that specific moment. It's kind of like handing a brilliant actor a sticky note with their lines and some background info right before they walk on stage.
Okay, so now we have a better idea of how it works under the hood. Now, let's get practical. How do we actually direct and control the output to make these tools reliable enough for our specific important tasks?
This is the million-dollar question for pretty much any business. Let's say you want a chatbot to answer questions about your company's internal expense policy. You upload the PDF. How can you be absolutely 100% sure it won't just ignore your document and pull an answer from some random blog post it was trained on 2 years ago?
And the honest answer is, with a standard model, you can't get a 100% guarantee. Now, you can use very careful prompting, saying things like, only use the provided source material to answer this question, and that helps a lot. It heavily influences the model. But you can't build an unbreakable wall around its pre-existing knowledge. It might still blend what you gave it with the vast sea of information it was trained on, especially if the topics are kind of similar.
This is exactly where a super powerful technique called retrieval augmented generation, or RAG, comes into play. Instead of just dumping a huge pile of documents on the LLM and hoping for the best, RAG acts like a smart research assistant. When you ask a question, it first searches through all your documents to find just the most relevant paragraphs or snippets. Then, it takes only those key pieces of info and adds them to the prompt. This grounds the LLM, focusing its attention on your specific data to help it generate a much more accurate answer.
But wait a second, technology is moving crazy fast. The latest models have these massive, million-token context windows. We can literally fit entire books into a single prompt now. So, the logical question is, if we can just stuff all of our documents into the prompt at once, is that whole selective RAG process even necessary anymore? The answer is a clear yes. RAG is absolutely still vital, and for three main reasons. First, relevance. RAG acts like a filter, finding the signal in the noise. Just dumping everything in can dilute the prompt with a bunch of irrelevant stuff, which leads to worse answers. Second, cost and speed. Processing 1 million tokens is incredibly slow and it is expensive. RAG is way cheaper and faster because it uses a much smaller, more focused prompt. And finally, accuracy. Research has shown that models often struggle with really long prompts, sometimes completely missing key details that are buried in the middle. It's a problem people call lost in the middle. RAG avoids this by putting the most important info right up front.
All right, let's talk about consistency. For a lot of applications, especially a customer-facing chatbot, you need predictability. If two different users ask the exact same question, you probably want them to get the exact same answer. Is that something we can guarantee?
You can get really close, but 100% guarantee on the exact wording just isn't possible directly from the model. There's a setting called temperature that controls randomness. If you set it to 0, it makes the model's output much more deterministic, so the meaning will be highly consistent. But because of all the complex math going on, tiny little variations in wording can still creep in. The only way to guarantee identical, word-for-word text is to use caching. You generate the answer one time, save it, and then every time that exact question comes up again, you just serve up that saved version instead of asking the LLM again.
So we've covered how LLMs work and how to control them. But that brings us to the most critical topic of all, reliability. Let's finally confront the elephant in the room: hallucinations, mistakes, and the huge challenge of telling truth from error.
This is maybe the single most important question in this entire field right now. Can we engineer a future where large language models simply do not make things up? Can these hallucinations, these confident, plausible-sounding falsehoods, be completely eliminated?
With the technology we have today, the answer is no. Hallucinations aren't just a bug that can be patched out. They are a fundamental, inherent feature of how these systems operate.
So why is that? It's because an LLM is not a fact database. It's a probabilistic engine. It's a complex network built to do one thing: predict the next plausible word in a sentence. Its main goal is to weave together words that sound coherent and statistically likely based on all the data it was trained on. It's not trying to state what is factually true. We can absolutely reduce how often they hallucinate by grounding them with facts using RAG, but we can never fully eliminate the risk that it will just fill in a gap with something that sounds good but isn't actually true.
Okay, so if we accept that mistakes are just going to happen and that a model can even invent fake citations that look totally real, the practical question becomes, what do we do about it? How can we build a quality control process that's both effective and efficient without needing a human to check every single thing it says?
A tiered strategy is really the most efficient way to go. Layer 1, automated checks. For structured things like computer code or SQL queries, you can run simple tests. Does the code compile? Does the query run? Is the JSON valid? Layer 2 is what we call an AI judge. You basically use another powerful LLM to evaluate the first one's answer based on a checklist you give it. This is super fast and scalable. But since the judge can also be wrong, you need that final layer. Layer 3 is human review. It's the slowest and most expensive, so you save it for the most high-risk, critical stuff. We're talking medical advice, legal documents, financial analysis, anything where accuracy is absolutely non-negotiable.
So after all that, we've established what an LLM really is. It's not a database, it's not a real-time learner, but it's an incredibly complex, probabilistic tool for generating language. So the real question then is for you. Knowing that it's a powerful but fundamentally fallible tool and not some magic oracle, how will you change the way you use it?